Okay, the third comment is about the data you have. You see, the LabPro, we sampled the data from the generator into 50,001 interval samples, or data point, 50,000 sample and 51 data point. So, those data are stored in the computer with one final step, and the step is 10 volts. That's the range we are going to sample, or has been sampled by your computer, by your LabPro, and the number was 50,000 interval, and so you have here 2.44 and millivolt, just millivolt. So what LabPro did, it divided your signal, that is 10 volts 100 times, so it's a long piece of signal, into 50,000 pieces. 50,000 pieces. Every piece has this length, 2.44 millivolt. But in your data, you don't see this. If you take two values, V1, V2, the delta is not 244. Every time it's changed every time. The reason is that when you record, when LabPro digitize those numbers, quantize them in sums like this, they are stored evenly with the same step, 244 millivolt. Now, when you display them or record those data, you display them as numbers or as a signal. They are actually reconstructed, like here. Here they are digitalized. Now, if I want to reconstruct, to display, like a table or plot, the computer first will read those numbers, and it will read with this step. And then what happens? It will reconstruct the original signal. And then what happens? Usually these computers comes with built-in algorithm to do some kind of interpolation. And so if there is no point here, probably you will put another point to make it looks nice. And so by interpolation makes the reconstruction more faithful. And so that's why you have different steps here. So the numbers you see here are not the numbers sampled, they are reconstructed. That's why we ask you to look for the aliasing, the distortion. Okay? So don't be surprised if the step is not even, because it is reconstruction. So the computer has to read first and then do some kind of work to make it look like the original one. So the original one is this one, the sample. Step, number, no number, number, no number. The computer will put extra here, interpolation, or other algorithm I don't know. Okay, that's the idea to keep in mind. But if you look here at the peak, you see the peak will converge, so the step is very, very small. So we might be lucky to find fine size of step, therefore we can find a decent n. The n, we know it is 12. You might find a number that is very, very close to